Welcome to this new lecture on ground improvement technology. Okay, how we can improve the present condition of the soil on which we are going to construct something like building, bridge, okay, or dam, etc. So to improve the soil conditions, okay, what type of methods are present, we will discuss in this lecture. Why we do ground improvement? Because to increase the shear strength. Okay, what is shear strength? Just like in concrete, the major property that concrete have, that is compressive strength, that is strong in compression but weak in tension. So the main property of concrete is compression. Similarly, steel have both tension and compression. And in soil, the main strength parameter is the shear strength. To improve the shear strength of the soil, we do the ground improvement. Reduce permeability, okay, to reduce the seepage, etc. Reduce the compressibility. Okay, if there is a very loose soil without the compaction, when we construct something, then definitely there will be so much compression or settlement. Okay, that will result the damage to our structure. Understanding ground improvement. Ground improvement includes two parts. First, understand the ground, means first understand what type of soil is present or what weak conditions of the soil are there. Then find out the most engineered solution for the improvement. Means then find out the most proper method for the improvement of that soil. Okay, engineered word mostly in the field used for different categories, like provide there are engineered field with the so much compaction, with so much dry density. Okay, so this engineered field means economical, safe and ease of simplicity to adopt. Okay, in the field. Okay, if there is a loose soil and if there is a organic matter is present, so to avoid the decomposition of organic matter, replace the soil with the engineered, means replace with sand and then compact. Methods for soil improvement. There are main three methods: ground reinforcement, ground improvement, and ground treatment. Okay, ground reinforcement have different categories. Similarly, ground improvement and ground treatment. We will discuss one by one. Okay, first of all, what type of failures happen without the soil investigation or without knowing what type of soil and what type of failure can occur with that type of soil. So for example, here tilting of structure, this is the most famous structure, Pisa Tower. Okay, that also due to the damage to the structure happened due to the soil condition underneath. Similarly here, leaning temple dome, Humma, Orissa, India. Okay, one side of the temple. A building at the Lotus Riverside complex in Shanghai, Minhai district collapsed due to the weak soil conditions. When the earthquake hits, the building tilted. Sinkholes. Okay, that is also the very damaging phenomena to the structures. Okay, that are sinkholes. Why these sinkholes form? Formation of sinkholes, basically rainwater collection happens, and if there is any SD content present from the factories or from the chemical industry, then the rainwater combined with the acidic water when it reaches to the ground, okay, underground. Then if there is any limestone present, acidic water react to the limestone and reaction happens. A reaction happens, then the cracks and cavities form. Okay, rainwater becomes more acidic as it filters through the soil. acidic Acid breaks down the limestone and cracks and cavities form, so that the upper soil may collapse. Okay, so that's why sinkhole form. Frost heave. Okay, if underneath there is some water, and due to the freezing, there may chances that the structure on which this phenomena happen may come above the ground. Okay, means some expansion happens on the ground. Or second condition is that if there is any expansive, means the soil which can expand like cotton soil. Okay, so if these soils absorb the water and expand. Okay, so these phenomena also happen due to the condition of soils. Overturned apartment complex, Niigata 1964, due to the soil conditions. Why we study geotechnical structure failure? Because we want engineered design of geotechnical structures. Means engineered means economical, safe, durable and strong during the lifetime of the structure. First of all, ground improvement. In the ground improvement, these type of techniques are present. Deep dynamic compaction we will discuss. Okay, in the ground improvement, what we do, we just improve the ground, the present condition by different means, by compaction. Okay, by increased soil density, removing air voids, pore water changing soil water properties. Okay, we remove the water, we remove the air voids, and we apply some methods to compress and to densify the soil. This is the ground improvement. Okay, ground treatment. In the ground treatment, we add some chemicals like cement, lime mixtures, fly ash, soil, and then we change the properties of the soil. Changing soil properties by adding soil, fly ash, slag, cement, chemicals, etc. Okay, it means that the modified property represent the property of mixture and not soil as an independent element. Okay, means now it's a modified property. In the ground treatment, we add some chemicals or addition so that the new property of the soil can perform better. The third one is the ground reinforcement. In the ground, same in the same way, just like we do in the concrete structures, we provide the steel to take the tension. Okay, to enhance the better property of the concrete. Similarly, in the ground reinforcement, we add some elements like stone columns, soil nails, deep soil nailing. We will discuss in the coming slides. So what happened in the ground reinforcement? Soil and reinforcing material act as a structure, one unit, in which reinforcing elements takes majority of load. Okay, if there is chance of collapse, then these reinforcing elements try to restrict that collapse. Now first of all, ground improvement. Okay, now you can get the better understanding, okay, of each method. First of all, ground improvement. Field compaction. Okay, you may have seen these type of rollers, okay, in the pavement compaction. Okay, equipment, smooth wheel roller, 100% coverage under the wheel, can be used on all types of soils. Okay, the most common use of large wheel smooth wheel rollers is for proof rolling subgrades and compacting asphalt pavements. Okay, it will remove the air voids present in the soil. Nowadays, vertical vibrator is also attached to the smooth wheel rollers. It means now these rollers have a function of the vibration also. Okay, when they move on the road on the soil which they are trying to improve, then these rollers can also impart the vibrations to the soil to get the better compaction. Pneumatic rollers, okay, mostly these types of rollers used on the asphalt pavements. Okay, 80% coverage under the wheel, can be used for both granular and fine grained soils. Okay, sheep foot rollers, these rollers have heads, okay, small heads of steel on the surface of the wheel. Okay, has many round or rectangular shape protrusions. Okay, these heads are called protrusions or feet, attached to steel drum, 8% to 12% cover to the soil. It is best suited for clay soil. Okay, it compress the soil, okay, and give the better compaction. Tamping foot roller. Okay, now there is just little bit change from the sheep foot, about 40% coverage when they move on the soil. It is the best for compacting fine grained soils. Dynamic compaction. Okay, first of all I will show what is dynamic compaction. Here is a crane, and crane drops heavy weights on the soil. Okay, for example, here drop from some certain height. Then when heavy in tons of load strike to the ground, that soil uh, becoming in the farm a more compacted farm, or in the compaction farm. Okay, existing why we do dynamic compaction. Existing surface or near surface soil is poor with regard to foundation support. Okay, so that's why we do dynamic compaction. For wet soil, both cohesive and cohesionless soils, means for clay soil that are cohesive soils, and for cohesionless soils that are sandy soils. How? Drop a very heavy weight, 2 to 20 tons weight, onto the soil from a relatively greater height, 20 to 100 feet. Okay, dropping weight randomly. A closely spaced grid pattern is selected. Okay, here that is the better picture. First, if there is going in the future, there is going to be construction. Okay, here is a first of all there are marking. Now uh, heavy weights are dropping from height so that the soil becomes compact. If there is any voids or loose soil is present, so that go for compaction. Again, dynamic compaction. Vibro-compaction, okay, or the vibro-flotation. Vibro-flotation is a technique for in situ densification of a thick layer of loose granular soil deposits. It was developed in Germany in 1930s. This technique is also very important and used in in various types of soils or in various countries. For example, in the Palm Island. Okay, in the Palm Island, the this technique is used for the compaction of sandy soil. Okay, how this works? There are four steps. Uh, at the head, there is a jet installed. When jet comes to the soil, jet try to replace the soil to the surrounding. Okay, the jet at the bottom of the vibro float is turned on and lowered into the ground. Okay, it start moving down. The water jet creates a quick condition in the soil. It allows the vibrating unit to sink into the ground. Okay, the vibro float start moving into the ground. Granular material is poured from the top. Now we add soil from the top. The water from the lower jet is transferred to the jet at the top of the vibrating unit. Okay, the water carries the granular material down to the hole. Now the water carries the granular material to the down. The vibrating unit is gradually raised in about 0.3 meter. Now it starts raising the densified soil granular material at the bottom. Okay, how much lift? 0.3 meter lift, and held vibration for about 30 seconds at each lift. This process compacts the soil to the desired unit weight. Means now under deeper depths we can compact with the vibro flotation. Preloading. Preloading means before the construction of the building we put some loads, okay, on the soil, so that if there is chances of settlement, soil can settle. If there is chances of some drainage, soil can drain. So this is called preloading. Okay, prefabricated vertical drains are composed of plastic core encased by geotextile for the purpose of expediting, okay, a consolidation of slow draining soils. First of all, see the figure here. There are two types with prefabricated vertical drains, without prefabricated vertical drains. Okay, here is the load. In the future there is some building or some structure will be constructed. Before the construction of a structure we apply the load. Okay, then some soil we put some soil just like here in the figure. Here some construction will be going to be held in future. We put the load on the soil, okay, then the water starts moving, okay, and the drain pipes are installed so that waters can come out from these pipes. Again here without pipes, here with pipes, okay. These are two methods of pre-loading or the vertical drains. Ground treatment, that is the second method. In the ground treatment, we add some material like cement, fly ash, blast furnace slags. Okay, these material added in the soil to improve the condition of the soil. Okay, here we add the material and then mix the soil in the other pictures here. Okay, when the grain material, okay, this rod moves into the soil, there are different functions. It also mix, and we can also insert the slurry, okay, means the material with the liquid. That is a good picture of a process of soil mixing. Okay, when it goes down, it also eject the slurry and also rotate in the soil. Okay, how it works, here we insert into the soil, and when it is inserted in the soil at the bottom, it start mixing and start moving upward. Okay, mixing and ejecting of slurry until it comes to the surface. Now this whole soil is with the are improved, and with the its shear strength is improved. It's if there is any voids, that are also removed, so that the condition of the soil is improved. Now the third technique is the ground reinforcement. Okay, the ground reinforcement, here when there is chances of landslide or anything, here here is the retain fill, pre-construction site. Okay, here are drains, pipe drains are installed. Here is foundation soil. Here is some road need to be construct. Okay, and here is the face of the retaining wall. To avoid this wall to move or tilt to the other side, uh, uh, this reinforcement is provided. For example, here steel bars are provided, and here some arrangements are made so that it do not go back. Okay, so these are soil reinforcement. Okay, here elevated highways. Okay, these all highways uh, are the example of the ground reinforcement. Grouting, injection of slurry or a liquid solution into the soil or rock formation. The grout subsequently hardens, increasing the strength and decreases the compressibility and the permeability. Okay, here see, here is the surface of the ground and here is a soil. We eject the slurry into the ground. Okay, it start moving. Okay, then we apply the pressure. With the applying of the pressure, if any weak surfaces or weak areas or weak stones are present, the grout material enters in their portions also. Okay, and when the grout material hardens, then the surrounding soil will get into the improved condition. Okay, that are the modes of grouting. The stone column. Okay, what is stone column? First of all, see the figure here. We eject the penetrating material that makes the hole, then we insert the stones, then after inserting the stone we also compact. Okay, we sometimes we also provide the vibration so that for better compaction, and do the process until it comes to the top of the soil. These are stone columns. Okay, now here stone columns, a ground improvement technique to improve the load bearing capacity and reduce the settlement of the soil. Stone columns consist of crushed coarse aggregate of various size. Okay, here you can see in the picture. Okay, now there are two types: bored rammed system. Crush is entered, then by hammering it is pressed. The second one is the vibro replacement method. In this method, with the hammering, The vibrations are provided for the better compaction. Here again the picture. Okay, here the funnel is attached and the crush is added. Soil nailing. Soil nailing is the method of reinforcing the soil with steel bars or other materials. Okay, here for example we make a ditch or a in the ground of 1 to 2 meter. Okay, that is the step 1, excavate slope. How we install the nailing, that is the procedure. Step 1, excavate small cut, then drill nail hole. With the help of driller, long drill, make the drills in the soil. Okay, that's the second step. Third, nail installation. Enter some steel rod and then enter the grout material. Okay, nail installation and grouting. Then the fourth step, uh, construction of temporary shotcrete facing. Okay, just temporarily surface of the slope is with the concrete is just temporarily. Okay, fifth step, then we go some deeper level and then again make a hole. Similarly, again hole, again hole. We are going down, okay, and making more holes and putting the nails. Now the sixth step, then final facing. Okay, and drain is provided. If any seepage comes, then the that can comes from the drain. Okay, here is again, that is a bigger picture. Okay, or you can say the section view. The steel rods, okay, are entered and the grout material entered when it hardens. Okay, that is very good resistance to avoid the tilting of wall to the other side. Now there is other technique, that is Gabions, that is mostly used in the hilly areas or where there is heavy chances of landslide. Okay, in this technique a steel mesh is made and the stones are entered in this mesh, steel mesh. Then it is arranged in a row, okay, that act as a wall. Now this stone, artificial stone wall, restrict the soil from the behind to move the other side. Okay, here drains are also provided for the drainage of water from the other side to this side, from the higher elevation to the lower elevation. Okay, you can also read the term Gabion refers to a modular containment. Okay, here a modular containment that enables rock, stone or other inert materials to be used as a construction material. Micropiles. A micropile is a small diameter, typically less than 300 millimeter, drilled and grouted replacement pile that is typically up to 20% area of steel versus area of concrete. Means uh, if this is a section of concrete, then 20% there will be steel. That is the ratio. A micropile is constructed by drilling a borehole, placing a reinforcement and grouting the hole. Okay, the micropiles can withstand axial and lateral loads. For the more better demonstration of micropiles, I will show you a video. Okay, first of all, where and how many micropiles are needed, that are also all are calculated. Okay, The last technique I will discuss in this lecture, that is geosynthetics, that is also very commonly used in the present era. What is a geosynthetic? Natural or artificial product that is used along with the soil in geotechnical construction, that is a geosynthetic. There are two types, natural and artificial. In the natural, there is coir, coconut fiber, jute, hemp, etc. In the artificial, that is polymeric or metallic, means that is made of polymers or metallic. There are different types of geomaterials, geosynthetics family. I will just show geotextile, Geo Grid, Geonet. Okay, different types of materials of in the geosynthetics. Here a geotextile. Here is a fabric material. Okay, here is a knitted, woven, non-woven. Okay, Geo Grid. In all these type of geosynthetics, what happens, the soil restricts in this or soil bounds in this geosynthetics, and soil particles do not move. Okay, Geonet, geomembrane, Geo-composites. Okay, Geofoam, foam like material, Geocell. Okay, that is also mostly used in the roads. Geocell description, Geomet, Geomesh, Geopipe. Okay, so all these geosynthetic materials are used for the ground improvement. Okay, summary of ground improvement. Here a summary is provided. Okay, reference is US Corps of Army Engineers. Okay, what method? Compaction, for example, compaction, all types of soils. Okay, what spacing? Definitely all soil will be compacted. Density will 95% density will be achieved. Low cost, simple. Equipment, soil compatibility, field control in the limitations, cost is low. Similarly, for every ground improvement method, this summary is provided, you can read. Okay, so that's all for today's lecture. Have a nice day.